All right, so we're going to start with this particular video, which is called proofs with triangles. We're using triangles to prove things, and ultimately we're getting at our ability to construct valid arguments and critique the reasoning of others. No one's ever going to ask you to prove things about triangles out in the world, but they certainly are going to ask you to prove your point about something, to construct an argument, to critique the reasoning of others. So, anytime someone's giving you information, you want to be able to look at it intelligently and decide whether what they're telling you is valid and truthful as we go. All right, so we're going to start with this concept right here, a straight angle. Yeah, a straight angle, it's just this line right here, is 180 degrees. Right? If I'm facing this way and I flip back the other way, that's called doing a 180. You've done it on skis or on a snowboard or on your roller skates or your bicycle or wherever you've done a 180, just standing in the hallway. So a straight angle, 180 degrees. So if I were to divide this straight angle into pieces, like if I just say, oh, like that, and I were to add these two pieces together, this piece and that piece have to add up to 180 degrees. So if this one's 30, that one's got to be 150. Sorry, I didn't give you time to think about that. But ultimately, that's one piece that we need to keep in mind. Straight angle, 180 degrees. Anytime we see a straight line or a straight angle, 180 degrees. Continuing. We have these things called vertical angles, which are like those two. They're right directly across from each other. They're vertical angles. Or these two are vertical angles. Okay? I'm going to just label them angle 1, angle 2, angle 3, and angle 4. Okay? Angle 1 and 2 make up a straight line, right? Okay, so angle 1 and 2, and I'm just going to write this sort of fancy like, the measure of angle 1 plus the measure of angle 2, because it's a straight angle, equals 180 degrees. I can also look at 2 and 3. The measure of angle 2 plus the measure of angle 3 equals 180 degrees. Okay? Since both things are equal to 180 degrees, I can now say that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. Both sides have a measure of angle 2, so I can subtract angle 2 from both sides, it's a number, and I'm left with the measure of angle 1 is equal to the measure of angle 3. Okay, measure is a number, so when I write measure up, I'm just talking about numbers. This number plus that number equals 180. So if the two angles have the same measure, that means the angles themselves are congruent. Okay, so angle 1 is congruent to angle 3. Okay, we'd mark it like so. Angle 2, because they're vertical angles, angle 2 and 4, they're also congruent to each other. Now, you probably looked at it and went, yeah, well, I can see that. But mathematically, we want to come up with an argument. We want to be able to explain it without having to measure every single possible angle that there is. So the thing about vertical angles, anytime we see vertical angles, they're congruent. They have the same measure. So if we know the number on this side, we know the number on that side. Okay, and we can figure out lots of little mini problems like that. Triangles. 20 degrees in a triangle. Oh, no. I bet you do. I'm just going to write it down. Are you right? I hope so. So that's just because someone told you. What we want to do is we want to set out to actually prove it, to come up with some sort of logical argument that says that it's the case. So what I'm going to do, hopefully, oh, that's kind of freaky. So I'm going to be able to take one of those copies of the triangles right there and line it up on my little line. I'm going to take another one, and I'm going to touch it right next to it. Okay? And I'm going to take a third one, and flip it over. I'm going to squeeze it right in the middle there. Okay? So even though you can't see the letters, I've got angle C right there, I've got angle A right there, and I've got angle B right there. Okay, and what do we know about angle C and angle A and angle B? What kind of angle do they make up? They make up a straight angle. Okay, and what do we know about straight angles from 2 slides ago? Straight angle, 180 degrees. How many degrees in a triangle? 180 degrees. Now, it's not really a great proof because we would have to do it with every possible triangle that we could ever imagine. We just did it with this one case, and that's not enough for us to say to say that it's the truth, but we're going to go with it for right now. It's kind of a proof by example. So we'll get to a more logical proof when we start math 2 with parallel lines and whatnot. But for right now, we're going to live with 180 degrees in a triangle. There's a reason for it. Okay. The other thing we could do is you could actually make a triangle, rip the corners off, and do the same exact experiment, and it would be delightful. Isosceles triangles. What's an isosceles triangle? Two sides are congruent. So boom, boom. Okay. What I'm going to do is I'm going to draw a little line in here that we're going to call an angle bisector. I'm going to take this angle up top here, right there, and I'm going to cut it exactly even. It may not be that way, you know, we're just going to say that it is, okay? So what I've done is I have, oops, pen, I've made an angle bisector. Okay, that's just awful. Angle bisector. So that means that this angle right here and that angle are the same. That's what an angle bisector does. Okay? In these two triangles, I've got that common side right there. Okay? And so I've got the common side. And so do I have this left-hand triangle, which we're going to call, I don't know, Jim and Jom, I think, or no, yeah, I don't know what that one's called, Mio. Are these two triangles congruent to each other? I believe they are. So triangle JIM is congruent to triangle OIM. I don't know what I was trying to spell. By which rule? Side, angle, side. A side, an angle, and a side. Congruent to a side, an angle, and a side. So if they're congruent to each other, that would mean that angle O and angle J are congruent to each other. Angle J is congruent to angle O. So if I go back to this isosceles triangle, which we know has two sides that are congruent, we also know anytime we see an isosceles triangle that the opposite angles are congruent. And we did that in a general case, so I did it with, but I didn't use any numbers. I did it for this particular one triangle, but it doesn't really matter. So every time you have an isosceles triangle, if you know it's an isosceles triangle, let's pretend that's one, these two sides are congruent, automatically you can say that these two angles are congruent. So if you know that this angle is 50, that one's 50. It's beautiful. So isosceles triangles. Exterior angles. This is an exterior angle. See why? It's an exterior angle of a triangle. It's outside the triangle. Okay? We're going to name this angle. I should have done that with a magic pen. We're going to name this angle angle 1. I'm going to get rid of that. I'm going to name this triangle, this angle, angle 1. We're going to name this angle 2, 3, and 4. Okay? 1 and 2, what do you notice? Straight line. So the measure of angle 1 plus the measure of angle 2 is 180 degrees. Inside the triangle, we've got angle 2, an angle 3, an angle 4, and they're 180 degrees. These two are both equal to 180 degrees, right? So I can say that angle 1 plus angle 2 equals angle 2 plus angle 3 plus angle 4. We got an angle 2 on both sides. Boom. Subtract from both sides, it's gone. So the thing about exterior angles, if I know the measure of angle 1, it's equal to angle 3 plus angle 4 together. Okay, so this one is total of those two. So if I know that these two are, I don't know, 70 and 60, the outside's got to be 130. If I know, this one and one of those, I can figure out the other one. It's all a giant house of cards, okay? So, exterior angle equal to the sum of the two remote interior angles, if you like, okay? But angle 1, the outside angle, is equal to the two that are far away from it, totaled up. Which leads us to be able to solve problems like this. With this particular little problem right here, given just that little bit of information, you could find the measure of this, 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 and this angle. Okay, if you want to take a second to stab at it, stop the video, work at it, and then join back in. Okay, I'll give you a second to stop before I start anything. If you want to just watch, you'll have to know how to do this eventually, but for right now, you can sort of watch and play along. So pause, work. All right, those of you that are still with me, great. Those that are back, that's fine too. So we're given some information. We've got a 110-degree angle here. We've got an 80-degree angle there. So we can figure some stuff out right away. This 110 angle gives me this angle because these two make up a straight line, right? So those have to add up to 180. So this one is 70. Okay? If that one's 70, this one's 70. Why? Because they're vertical angles. Okay? If this angle is 70 and this angle is 80, can we get this outside angle? Well, we know that those two have to add up to the same as that one, so this outside one is 150 degrees. And because these two add up to make a straight line, 180 degrees, that one's got to be 30 degrees. Or we could make sure, 30 plus 70 is 100, plus 80 more is 180, so we've got 180 in the triangle. Okay? This one, let's see, what do we have here? We've got an isosceles triangle, so we know that these two angles have to be the same, right? Okay, and we've taken 70 degrees away from the triangle, so there's 110 to split between these two angles here. So if I divide that by 2, 110 divided by 2 gives me 55 for this one and 55 for that one, which incidentally adds up to the 110 that we have out there, right? If this one's 55 by vertical angles, that's 55. Okay, and then what do we have left? We have 55 and 35, which is 90. So 180 subtract 90 gives me this guy here, which is 90 degrees. So with just a little bit of information, we can get a lot of information about these triangles just using these properties that we've talked about. And again, 180 degrees in a straight line, vertical angles being congruent, 180 degrees in a triangle, and then we sort of play with that exterior angle, and we used isosceles triangles. All those pieces together to get that. Not bad. Little addition, little subtraction, and we've constructed some arguments and talked our way through it. That's about all we have on this one, so I appreciate you watching, paying attention, listening, doing the things that you do, and we'll talk to you real soon. Hope you learned something.